In these next problems, we're going to use the graphing calculator with the table function in much the same way we did previously. However, here you're not given the values, so you have to look at the limiting value and to come up with your own table of values to use. So first we'll look at problem number 9, and there we're looking for the limit as x approaches 1 of x minus 2 over the quantity x squared plus x minus 6. So we need values that approach 1 from the left and values that approach 1 from the right. Now we could make a horizontal table similar to the ones that are shown above there, the ones that we've worked with already, or we can use a vertical table. And the vertical table is usually easier for me to write and save space here. So approaching 1 from the left. As we're approaching any number other than 0 from the left, we're going to use, well, positive numbers. We're going to use 0.9. If we were approaching a negative number from the left, we would use 0.1. So we'll use 0.9, 0.99, 0.999. Approaching from the right, we'll use 0.1. And it's the opposite for negative numbers. For negative numbers approaching from the right, you would use 0.9, 0.99, etc. So we'll start off with 1.1, 1.01, and 1.001. Now we'll bring up the graphing calculator, put our function in, and that's parentheses for the numerator, x minus 2, divided by parentheses for the denominator, x squared plus x minus 6. Now we're ready to go to table set. Make sure that it says independent ask, which it does. Then second table, and we're ready to start entering values. 0.9, 0.99, 0.999. And so we got the values 0.25641, 0.25063, 0.25006. So it appears that the value that we're approaching is 0.25. Now we'll approach from the right, 1.1, 1.01, 1.001. And once again, it does appear that we're approaching 0.25 as we approach in from the right. It's not as clear as approaching in from the left, but if we get to 0.24999, then that means that we're 1/10,000th or 1/100,000th away from 0.25. Okay, we'll go on to the next one, problem 13. Here we're approaching 0, so we want values from the left. We're going to use negative 0.1, 0.00, 0.01, 0.001. And we'll go ahead and enter the function. It's sine of 2x over x. And so we only need parentheses around the 2x there. And we're ready to go. We check the table set. We go to table. And we're ready to put in values on top of the other values that are there. And we start with negative 0.1, negative 0.01, negative 0.001. And we have the values 1.9867, 1.999, and 2. Once again, just to put the cursor on top of 2, we see that it's not exactly 2, but it's 1.9 with 5 nines there. So the calculator will round it to 2. As we approach from the right, we're going to use similar values. Since we're approaching 0, we're also going to use 0.1, but from the right this time. And so we'll use the values 0.1, 0.01, 0.001. And we're ready to put those values in also. 0.1, 0.01, and 0.001. And we have the same exact values as we approach from the left and right, so this would be considered an even function here. But the value that we're approaching is definitely 2 from the left or the right. And a little correction, that is problem number 13 and not problem number 11. And we'll see if we have time to do problem 11 here. Okay, so I've put the expression for problem 11 in, parentheses x to the 4th minus 1 over parentheses x to the 6th minus 1. And we're approaching the value of 1. And so as we approach from the left, it will be similar to the previous problem, or to problem number 9. And approaching from the right will be the same also. And to save time, I've listed all the values there and gotten the values for the expression also. And from this, we can see that we're approaching a limiting value of 0.666 or 2/3. And that'll do it for these 3 problems and for this video.